Hi everyone. In this video, we are going to talk about the margin of error. This is the last video for this course. Let's do it. The title is Confidence Interval and the Margin of Error. Here I list some objectives for this video. First, we want to understand the difference between a sample and the population. And then what is a statistic? What is a parameter? And then we want to learn how to calculate the margin of error, and then how to calculate the confidence interval, which is closely related to the margin of error. And then finally, we're going to connect all of this together. Okay, population. Population is all of the people or all of the items under your consideration in your research. For example, if we want to know how many percent of people, how many percent of all of the voters support Trump during that last year election, and what is population in that case? The population is all of those voters, more than 150 million of them. But usually when people do a poll to find out how many percent of voters support Trump and how many percent of people support Biden, usually they take a small number of voters to ask that question. Are you the Trump supporter? Are you a Biden supporter? And such. So usually they do 2,000 people, maybe 3,000 people, and that 2,000, 3,000 is called a sample because it's a fraction, a very small fraction most of time of the population. So in other words, a sample is just a subset of a population. So that's a relation between sample and population. So whenever you do calculation using the population, that calculation is called a parameter. Instead, if you use a sample to do the calculation, and that calculation itself is called a statistic. So statistic is just a calculation, it's a measurement based on the sample. For example, and if you suppose we are able to do that, okay. So if we ask all of those more than 150 million voters, and are you going to support Trump? Are you a Biden supporter? And then we calculate the percentage, right, among the whole population. How many percent are Trump supporters? How many percent are Biden supporters? And that percentage, whatever the number is called a parameter, because we get that percentage using the whole population to do the calculation. Instead, if we only ask 2,000 people, which is a sample population, the same question, then we calculate how many percent out of the 2,000 people are Trump supporters, how many percent are Biden supporters. And that percentage, whatever it is again, is being called a statistic, just because it is calculated based on the sample. So I hope I make this part clear. Now the third one, how do we calculate the margin of error? And let me say this, calculation part is very easy to do. Very easy to do, but we want to have some basic understanding of this margin of error. Why do we have that? Why do we have the margin of error in the first place? When we use a sample to do calculation, in real life, most of the time in statistics, when we do any calculation, we use a sample because most of the time, it is very time consuming and costly if you use population to do calculation. For example, if we want to know how many percent people among all of the voters support Trump, are you going to ask all of those more than 150 million voters one by one? By the time you finish that, the election is over a long time ago. So usually we don't use population, we use a sample to do all of the calculation. When we use a sample, which is not population, we expect some kind of inaccuracy, because you want to know about the population, but you do calculation using sample. Certainly, there's some kind of difference, right? And that difference result in the inaccuracy to some level of your measurement. And that inaccuracy is measured by the margin of error. So margin of error is expected. It's just a matter of how big it is when we use a sample to do the calculation. So now apparently this margin of error, this amount of error is dependent on the size of sample. The bigger the sample size, the smaller the margin of error, and which is makes sense from, even if from a common sense point of view, it makes sense. The bigger the sample size, the smaller the margin of error. That is because when you increase the sample size, and you get more data to calculate, to do your calculation, right? And you keep increasing that until your sample equals population. When that happens, guess what? There's no error anymore. You use whole population to do calculation. That's why when you increase the sample size, your sample getting closer to the population, your error going to shrink until zero when your sample size equals the population size. I hope this makes sense to you. Now it's time to do an example, and then we introduce the formula to calculate the margin of error. Now let's look at this example here. What was the average ACT score for 2019 for Wisconsin high school students? This is about what is a population. Since we want to calculate the average ACT score for the year 2019 for Wisconsin high school students. So population first has to be Wisconsin high school students, and those high school students have to be from 2019, and that's your population. You calculate average ACT scores for those students. A sample is just a subset or a fraction of the population. So we already mentioned that. Now let's look at a real example here. And this is the formula to calculate the margin of error. So it looks like very simple formula. And N here is a sample size. Apparently, the margin of error depends on the sample size, right? Now, when we increase N, when we increase the sample size, the result of this calculation will give us smaller margin of error, which makes sense, right? We just explained that. Now let's look at some numbers to see why does this make sense. So one, say, I use some special number so that we can calculate this easily without a calculator. Other than that, any number will do, okay? As long as you have whole number, because this is the sample size has to be a whole number. Say if this is a 4, square root of 4 is 2, right? So you got a 0.5. That's your margin of error. Now let's increase that to 400. And square root of 400 is 20. So 1 of 20, 0.05. Now let's increase another one, getting even bigger sample. Let's do 10,000. How about that? 10,000. And then square root of 10,000 is 500. You got 0.01. You see, as the sample size increases from 4 to 400 to 100,000 to 10,000, look at your margin of error, 0.5, 0.05, 0.01, getting smaller, and smaller. I hope that makes sense to you, because when you increase sample size, you're getting closer to the population size. That means your error should get smaller, because population has no error when you use population to do calculation. And after this, notice that in this formula, I don't have exactly equal sign here. Instead, we have this like small titles. So what is called? This is called approximately equal. It's not exactly equal. Why we have this? So this is the result of math department discussion. We just decided to reduce the original formula to this one so that you don't have to deal with complexity of that formula when you do the calculation. At the same time, even though we simplify the original formula, the result using this simplified version of formula will have no much difference than the original one. That's why we are able to do that. Otherwise, they cannot do just simplify that formula. Again, this is a simplified version of the formula in any college textbook, and you use this one to do all of your calculation. And another thing you need to know is that this formula is only good for 95 of confidence interval or confidence level, 95% of confidence level. Later on, you will understand this, what is a confidence level in a natural way. Okay, after that, we are ready to have this formula to look at this formula to calculate a confidence interval, which is calculated using the sample statistic. Sample statistic, and let me drop this as plus minus margin of error. So let's use example to demonstrate this part so you have a concrete understanding. Now this is the example. At 95% confidence level, 58% of Wisconsin high school students scored 21 or higher in 2019 ACT test. The margin of error is 2.3%. So what does this mean? What does this mean? First, whenever we talk about confidence level, and we want to create a confidence interval first. Interval like brackets. You have lower bound number, you have an upper bound number. So let's do that. And that confidence interval is created by sample statistic plus minus margin of error. We are given margin of error 2.3%. What is the statistic? That's a measurement, right? Through the sample. So we are given this. This is the measurement result after they do the survey. 58% of all Wisconsin high school students in 2019 who got 21 or higher, 58% of those. So this is our statistic. If you have some kind of confusion regarding how to identify which one is the statistic, that's an easy way to do that. Statistic always has same format as margin of error. If margin of error is percentage and statistic is percentage, confidence level is not a statistic. It's how confident you are about this number. So this one is not calculated, it's predetermined. That's out of scope of this course. Now let's calculate this confidence interval. This is how you do that. For the lower bound, using this statistic minus the margin of error, which is 2.3%. So when I do that, I get 55.7%. Now, upper bound is this statistic plus the margin of error. And this is 60.3%. See, we create a bracket from 55.7% to 60.3%. Now, let me give you an explanation so that we can understand all of these terminologies: confidence level, confidence interval, and margin of error. So let's do that. And there is this interpretation itself. Since we use, by the way, since we use a sample to do calculation to understand how many percent of all of the Wisconsin high school students who took ACT test in 2019 and got 21 or higher. We want to know that percentage for all of the students. But since we didn't use all of the students to do the calculation, there's no way we can know the exact percentage. This one is the one we get using the sample. So this one will have some kind of error in it. That means this one should be close to the true percentage, which we don't know. But we do, there's no way we know the true number without using all of the population. That's why we have some level of confidence in this, but not 100%, because we know this is not the exact number. That's why we have confidence level. You can say we are 95%, 95% confident that the true number, true percentage will be between these two numbers. That's one way to see that. Another way to see that is that there is 95% of chance that the actual percentage of Wisconsin high school students in 2019 who got 21 or higher in the ACT test, and the actual percentage will be between these two numbers, will fall in this interval. There's 95% probability, likelihood. The true percentage will be between these two numbers. And that is interpretation. That's why whenever we talk about interval, we will have this confidence level, because this formula to calculate the margin of error is based on 95% confidence level, 95% likelihood. And after we get that, this margin of error, we use margin of error with sample statistic to create this confidence interval. So in other words, this confidence interval is also related to that 95% confidence level. That's why we also call this 95% confidence interval. Okay, now let's look at another example here. Example, a survey of 1,500 adults found that 57% of those surveyed believe that it should be legal for gay and lesbian to get married. So two questions: find the margin of error and 95% confidence confidence interval here for the survey, and interpreted the survey result. First of all, and we only deal with 95% level. That's why they mentioned that. So the formula for the margin of error at 95% confidence level is 1 over square root of the sample size, right? So 1 over square root of 1,500. And let's do the calculation. Usually we keep one decimal digit in the percent. So let's do the calculation. 1 divided by square root of 1,500. And make sure the cursor come out. So in order to have one decimal point in percent, I need to keep 4 decimal digits. So 0.0258. That's 4 decimal digits. When I convert it to percent, I need to move 2 digits to the right to get a percent, 2.58%. Now I can round it to 1 decimal digit. That's why I have to have 4, so that I have 2 decimal digits in percent, so that I can round it to the 1 decimal digit in percent. That's 2.6%. That's our margin of error. Now I can create 95% confidence interval. This is the interval. By using the statistic, which is 57%, because it's a result of measurement this sample, 57% of those surveyed. So this one is related to the survey. Okay, that's a measurement. So we use a 57%, subtract 2.6 to get the lower end of the bracket, which is 54.4%. And we use this statistic plus 2.6% to get the upper end of the bracket. This is 59.6%. So we have this bracket from 54.4% to 59.6%. Now interpretation part. And basically it's like a template. You follow this kind of format here, starting from here, basically. This is how you interpreted it. So if I use the same format, I would say there is 95% of chance, so always 95% chance, because in this course, we only learn the margin of error formula for 95% confidence level. That's why there's always 95% of chance. So there is a 95% of chance that the actual percentage, of adults who believe it should be legal for gay and lesbian to get married. And the actual percentage will fall between these two numbers, because we don't know actual percentage, because this percentage is calculated based on the sample. We never did that based on the population. So we will never know if we don't do that. That's why we have a interval to hold the actual percentage. And how likely the actual number is in this range is 95%. And that's good enough in many applications. That means if you have 95% of chance for a number to be in this bracket, means more than likely it will be in this bracket, because 95% of chance. Okay, let's look at another one. This one is called exercise. Basically, it's very similar. I just do it as an example here. A survey was conducted of 456 teenagers. 34% of those teenagers said they occasionally smoke cigarettes. Interpret the margin of error in terms of 95% confidence level. They don't have to say level. 95% confidence is 95% confidence level. So again, we need to interpret that. So we need to calculate the margin of error and the confidence interval at 95% confidence level. So let's do that. And basically, sample size 1 over square root of n. That's we already know that. So margin of error equals 1 over square root. We have 456 teenagers surveyed. So let's do this part first. 1 divided by square root 456 equals, let's read it directly, 4.7%. 4.7%. That's margin of error. Now let's look at our interval, confidence interval. So I use a statistic, which is 34%. That's how that's a percentage they found through the sample. So that's a statistic, right? 34% minus 4.7%. So if you use 34 minus 4 is 30, you have to minus another 0.7. The red is 0.3, so 29.3%. Now 34% plus 4.7%, that'd be 38.7%. Now we have our interval. Now we can do an interpretation. So there is 95% of chance that actual percentage of teenagers who said who occasionally smoke cigarette is between these two numbers. That's interpretation. Now conclusion. After that, we just do several more exercise problems. And conclusion first, this formula is based on 95% confidence level. And the higher the sample size, the smaller the margin of error. So we already demonstrated that in the very beginning. The smaller the margin of error, the narrower the confidence interval. So why this is true? Remember how we construct or how we create confidence interval. We use the sample statistic plus minus margin of error. Margin of error is just a number. Don't forget that. Let's say when you plus minus, you put this number, whatever it is, in the middle. Say, for example, this is our sample statistic. Then if your margin of error is this big, whatever this number is just this big, when you subtract this number, you get a number at the left end. When you add margin of error, you get upper end to the right of this middle number, which is your statistic. So this is called confidence interval, this distance. This for this margin of error this big. But if you have a bigger margin of error, you subtract bigger number, you get even smaller number. When you go to the left, number gets smaller, right? When you add a larger margin of error, you get even bigger number to the right. So that's your new confidence interval. So it depends on margin of error. So you can see the smaller the margin of error, the narrower the confidence interval. The bigger the margin of error, the wider the confidence interval. And it's just true. Okay, now we are ready to look at the exercise. Find the margin of error and 95% confidence interval for the survey result. So this time they didn't ask us to interpret it in the end. So we just need to find margin of error and confidence interval. So margin of error equals 1 over sample size inside the square root. So 1 over square root 1998. So let's do that calculation. Divided by square root 1998. So 2.2%. 2.2%. Now interval, confidence interval. And lower bound, this is our statistic. So 42% plus 2.2% minus 2.2%. So 42 minus 2 is 40. 40 minus 0.2 is 39.8%. And then 42% plus 2.2%, that's 44.2%. So that's our interval from here to here. Now we finish that. Now look at the next page. And looks like we have 3 more questions here. Using random sample of 4,000 households, a media research company found that 55.1% watched a particular episode of a popular situation comedy. Interpret the margin of error in terms of 95% confidence. Whenever they ask us to interpret the margin of error, we need that confidence interval. So let's do that calculation of error equals 1 over square root of sample size 4,000 equals 1 divided by square root of 4,000. So 1.6%. And then we can calculate the confidence interval. And we get 55.1% minus 1.6%. Now, if I multiply 1.1%, I'm going to get 54. So I need to get minus another 0.5. So 54.5, 53.5%. Yeah, 53.5%. Upper bound is 55.1% plus 1.6%. This gives us 56.7%. Now, interpretation is that there is 95% of chance that the actual percentage of all households who watch this particular episode of comedy is between these two numbers, 95% of chance, the true percentage is between these two numbers. Okay, next one. Find the margin of error and 95% confidence interval for the survey result. Survey result described below. So we don't need to interpret that. So margin of error equals 1/500 because I only surveyed 500 people. So by this point, I guess most of you already realize they're all the same, all of these problems. Divided by square root of 500, we get 4.5%. Make sure you do rounding correctly. Now the interval, use a statistic which is 6% minus 4.5%, and that's 1.5% lower bound. 6% plus 4.5%, and that is a 10.5%. Now we finish that. We don't need to interpret the margin of error. Now the last one for this video, and find the margin of error and 95% confidence interval for the survey result described below. Pretty much the same thing. We don't need to interpret it again. 1/, I got 1,500 people this time. 1 divided by square root 1,500 equals 2.6%. So 2.6%. And the margin 95% confidence interval. Our statistics 87% minus 2.6%, that's 84.4%. Then we have 87% plus 2.6%, and that is 89.6%. And yeah, it didn't say anything about interpretation, that's it. And see you guys in the next video.